let us discuss a few more problems on limits which can be solved using L hospital rule. So in previous class I have given two problems as a homework. So that is, one is limit of x tends to 0, 1 minus cos x divided by x square. This is equals to 1 by 2, because by L hospital rule the derivative of 1 minus cos x will be sin x in the numerator, and derivative of x square will be 2x. Again it is in 0 by 0 form, therefore if you differentiate it again, derivative of sin x is cos x here, and the derivative of 2x will be 2 is equals to 1 by 2. So this will be very important result, because I'm going to consider few more problems on this particular result itself. So limit of x tends to 0, 1 minus cos x divided by x square is equals to 1 by 2. Try to remember this, it will be very useful for upcoming problems. So another problem is there, another two problems in fact. So one is limit of x tends to 0, 1 minus cos x divided by 1 minus cos nx divided by 1 minus cos mx. So I've solved in this particular part. You can easily get the answer as n square by m square. And similarly for this problem, I have given the solution here. Okay, so let us try to solve next problem. So now here again we have two problems. First one is limit of 1 minus cos 7x divided by 1 minus cos 9x as x tends to 0. So as x tends to 0, clearly it is 0 by 0 form. Therefore, if you differentiate it, then numerator will be sin 7x divided by, into 7, here it will be into 7 divided by sin 9x into 9. Again it is 0 by 0 form, because if you substitute x tends to 0, sin 7 into 0 will be sin 0 divided by sin 9 into 0 will be sin 0. Therefore differentiate it again. Therefore derivative of sin 7x will be cos 7x into 7, but already we have 7, therefore it will be 49 divided by sin 9x. Derivative of sin 9x will be cos 9x into 9, already we have 9, therefore it is a 49 by 81. Now if you apply limit of x tends to 0, cos 0 becomes 1, therefore the answer for this one will be 49 divided by 81. So option C. The main intention of all these problems, you should learn how to apply this L hospital rule, that is, find the derivative of numerator separately and derivative of the denominator separately. Again if it is 0 by 0 form, again differentiate numerator and denominator separately. So in the same manner, let me consider this second problem, limit of 1 minus cos 4x divided by x problem. Again as x tends to 0, it is 0 by 0 form. Therefore derivative of 1 minus cos 4x will be sin 4x into 4 divided by derivative of x will be 1. Now, so if you consider this one, then it is free from 0 by 0 form. Therefore, apply x tends to 0. If you apply x tends to 0, sin 4 into 0 will be 0. 0 into 4 divided by 1. Hence, the answer will be 0. Therefore, option A will be the answer. So, next problem, limit of sin phi theta divided by sin 3 theta divided by theta. Again, if you apply theta tends to 0, it will be 0 minus 0 divided by 0, hence it is 0 by 0 form. This is the main hint for all these problems, 0 by 0 or infinity by infinity problems. Okay. So now, if you differentiate numerator, so again I'm not writing limit of theta tends to 0 in each and every step, because in competitive exams you need to save your time. Okay, that's why. So here now, sin phi theta, derivative of sin phi theta will be cos phi theta into phi, it will be minus cos 3 theta into 3 divided by derivative of theta will be 1. Now if you apply theta tends to 0, cos 0 will be 1. Therefore the answer will be 5 minus 3 divided by 1 is equals to 2. Hence option A. So all these problems are of same kind. What you need to do? Differentiate numerator, differentiate denominator, then apply the limits. Next one. So it's a old Karnataka CET problem 2000 in the year 2000. So here again a raised to sin x minus 1 divided by b raised to sin x minus 1 as limit of x tends to 0. If you apply x tends to 0, sin 0 becomes 0. A raised to 0 becomes 1. Therefore again it is a 0 by 0 form. So if it is 0 by 0 form, what we need to do? We need to differentiate numerator and denominator separately. So a raised to sin x. First of all, what is the derivative of a raised to x? It is a raised to x into log a. Therefore, this is a raised to sin x into log a into derivative of sin x, because it is a composite function. Derivative of sin x becomes cos x divided by, in the same manner, it is a b raised to sin x into log b into derivative of sin x will be cos x. Therefore, this cos x and cos x get cancels. Next, now if you apply x tends to 0, a raised to sin 0 becomes 1 and b raised to sin 0 also becomes 1. Therefore, we only remain with the log of a divided by log of b. So look at these options. Here we have option A.